Okay, hello guys. Today I'm going to walk you through creating a Postgres database and connecting to that Postgres database and running some create, read, update, delete commands on the database. So I'm going to start by I've already installed Postgres on my local machine. I installed it using brew, just you can just run brew install PostgreSQL. You can be more specific and provide your version, or you can just run this, which will install the latest version, the latest stable version for you. Okay, so since I have Postgres installed, I can just run this and I'm in. Since I have a user called it has locked me in with that user. So we can start by creating a database called playground database, and this, when it shows this, means our database is created. So you can exit from that database and connect to the database from this point here. I'll just create, this is Table Plus. It's a software which acts as a database client, enabling you to be able to connect to your database. It just gives you an easier to use UI compared to writing commands on your terminal, which is still very possible. So we're just going to create a new connection to Postgres. We'll call it for playground database connection, and everything stays the same except username is this, the password, the password, and the database name is playground underscore database. So we're going to test, and it looks like everything is good. So we have our database here, and we're going to start running commands. So we can start creating a table. To create a table, we will use the command used for that is called create table. Then we specify the table name. So I'm going to name the first table with products, and then we open parentheses, and we then give key value pairs, which are like the name and the type. So we have ID, which is going to be a serial, and it's going to be a primary key. And we have the next name, which is going to be, so we have the name, the attribute name, which for this case is name, and we give a space with tab whatever we choose to, and we declare the type and the constraints and everything. So name is going to be of type varchar, we can say 100 characters max. Description is going to be varchar2, or we can just give this a text. It's gonna have a created at timestamp, the default is now, and lastly we can have the updated at, which is also a timestamp with default of now. So that's it for our name for our products table. So products table has an ID, which is a primary key. Serial just means that it's going to automatically increment one number after another, so it's going to be like 1, 2, 3, and so forth. So when you create a table, I can just say select everything from, after retrieving it from products, and it's going to fetch that. So there's currently nothing. So say we were to insert some data into the products table, what command do we use? We will use the insert command. Insert into products, and we specify the keys here. The keys, we could have name, description, created at, and updated at. Okay, give me the values of name is first product, description first nice product, and lastly it's going to be now, and it's going to be now. So we specified the we specified all of the keys here at this point here, because we wanted to follow this particular order, and to make sure that the keys here are matching exactly to the values here. But since we have already done this, we sometimes we don't need to specify this here again. It's just there for clarity. If you want this, it will still, what's the issue? No, it's going to complain about the ID, so it's preferable we have that there. Yeah, so it just tells it the order in which we want it to go to. So the next thing we want to do is learning about updating. So if I were to open the products table, here it is. We have the two things we created. Let's see, we want to update all product names with the name of first product to be now second product. So we can do that now here with the update query. So we can see update products like that. We set name to be equal to second product, and then where the name is currently equal to first underscore product, and we can run this and we're done. If I refresh this, just updated. So what's something we want to do? We've learned about now how to update our items. Now let's see, we want to add a new column called count for product counts. Let's say product counts. So we can alter our table called products, and then we can add a new column, and then we call it product underscore counts equal to, and then we say this is an integer with a default value of 0, and we could just include a check, like check that the count product underscore count should be greater than 0, like that. Don't see a point of a product existing if there is no product count. And we have an error. Says check constraint product counts of relation products is violated. So here we did see that default value is 0, and then we came on saying that if it's greater than, it must be greater than 0. So we can just add an equal to here. Greater than or equal to, not equal to, like greater than which equal to, like that, and it works. So if I were to go to products and refresh it, you will notice that all the product counts are now 0. Now let's talk about deleting some data from our table. So if we want to delete the product with ID 1, we can just go here and when you query delete from products where the ID is equal to 1, and that's it. Sounds like English. Enter and your product one is deleted. So what if, let's try creating another table so we can try playing around with dropping of tables. So we could create a new table called test underscore table, and you just give it a single value, item of type integer, and we are done with that. Run it. So we have a new table called test tables here. Test underscore table, which test underscore table, like that, with one single item. Now see, we wanted to delete that table. We are tired of using the test table and we are ready to delete it so we can send it out to production. What do we do? So we can just simply run the command drop table test underscore table, and this is going to drop the table. Interesting. What if we wanted to drop our entire database? I don't know if we can be able to do that here within the database itself, but let's try saying drop database, and I'm going to read this database name here, which is called playground underscore database, like that. Cannot drop the currently open database. Yeah, but if we were not in this database like now, we could do, let's say psql-u. If we, let's say I was logged in as someone else, currently as a different user, I could drop that database called playground what should I call it, test database. I think, yeah, was test database, so it has been dropped. A nice way to check all the databases that are available is to run this command to check database name from pg underscore tables. Oh, it's pg underscore database. That's an error. Underscore database, and yep. So we have playground database available. I can run the drop command on playground database, playground underscore database, and hit enter, and it's gone. Oh, I need to drop drop this using for the app db, and done. So if I were to run that command again, we see we now have 7 databases instead of 9 databases. So that's it for this video. Just wanted to walk you guys through some of the some SQL commands for Postgres databases. So with that, see you in the next video where we explore more on that.